The cosmic question for me is HDFS a good custodian of Yahoo's data? You've heard from other people from Yahoo today about the scope of the use of HDFS at Yahoo. It's many petabytes, it's 42,000 nodes, it's millions of files each day, it's hundreds of jobs a day, millions of jobs a month, and this is all critical data for Yahoo's business. It's said that there's no dollar of revenue at Yahoo these days that does not some way depend upon Hadoop processing. And this has progressed from being just sort of Yahoo's back office to being in the core stream of revenue for Yahoo. If HDFS breaks right now, before I finish speaking today, Yahoo will start losing money. And so this is an important question of whether HDFS is a good custodian of Yahoo's data. Loosely, the job of HDFS at Yahoo can be described as 60 petabytes online all the time. And what I want to do today is look at how close we are to meeting that goal. The program committee today advised me that I need to be very succinct about just how well we've done. And so here's the answer. I'm not just being cute here. There's actually some engineering behind these numbers, which we'll get into. But what I want to do is first of all, convey the message that, yes, HDFS is a good custodian of Yahoo's data. And answer the question from an engineering perspective of how do we know? Engineering, a big system, and we're talking about big systems here. We're talking about 60 petabytes. These are tens of thousands of nodes. These are clusters which have often 4,000 nodes belonging to them. And so engineering at this scale has interesting behavior if you look closely enough. And so what I want to do is look closely, and look at the sort of exceptions to just running all the time and see what can be learned from that. But if you really want to go away from here with a quick executive summary of this presentation, it is that yesterday evening, nobody from Yahoo went to bed worried about their data on HDFS. What I want to do now is see whether that was prudent of them and look at how we might know how that works. And so the process I went through for doing that is approach this from kind of two perspectives. One is the data durable. A file system, at the very least, you write a byte, you come back the next morning, you'd like to think the byte is there, and we'll look at that problem. The other part of that is availability. You wrote a byte, you come back, and you want to know whether the byte is there or not, and do you get an answer to that question? And so that's a different part of the problem, but we'll look at that too. And I think the fun thing about this is not only the conclusion of how well HDFS does as a file system, but by looking carefully, you get some insight into how HDFS works that I think will be interesting to a lot of people. If you are an executive, you're welcome to stay around for that part of the talk too. The key to durability of HDFS is replication. Yahoo has not lost data replicated 3 times due to the uncorrelated failure of cluster nodes. Those words are chosen very, very carefully. And what I want to do is explore the carefulness of that and what the alternatives to things like 3 and uncorrelated and nodes mean. Just from a statistical perspective, if you do some naive queuing theory on the question of, is data at risk because 3 nodes just happen to fail simultaneously. For our large clusters of 4,000 nodes or so, 1 or 2 nodes will just die every day. And you can use that rate, and you can do a little arithmetic, and you can conclude in the, like, today, it's about 1 chance in 10 million that a block will be lost because 3 nodes just happen to have failed before HDFS noticed the failures and was able to recreate replicas on other nodes. It's like a failure in the coming years, a probability of like 1 in 10,000. I'm almost certainly going to retire from Yahoo before anybody comes to my cube complaining that, aha, we got caught this time and I want you to take responsibility for that. But during a survey year, this is approximately a review of the year 2009, every time the name system reported that a block was missing, in the sense that there was a block in the metadata that had no, apparently had no replicas, that report ended up on my desk. And so here's a summary of those reports for the year 2009, sorted by clusters. The funny names on the left are just the way Yahoo has chosen to name clusters to get some perspective of what size of problem we're talking about. I have included the number of nodes in the middle column for those clusters, the number of blocks that were active on those clusters. For purpose here today, a block is a file, and the number of new files that were created on average per day on those clusters. And recall that this is the year 2009. Since then, since these statistics were taken, the scope of HDFS at Yahoo has approximately doubled. So if you want to know where we are today, you can kind of double the numbers at the bottom of the page. And so the blocks reported lost are in the second column. And you see that Axonite blue and dilithium gold had no reports of loss, and dilithium blue, couple, and kryptonite red, a couple, and mithril gold, one of our problem children, showed up with 533 some missing blocks. And mithril blue, a block or 2 there, and finally down to M45, which is the cluster that's shared with the academic research community. And another kind of special case. And so during this period, survey period, we really did do a block-by-block analysis of reports of missing blocks. Mithril gold, who is special here, nearly all of those blocks were lost in a short period of a very few, 4 or 5 weeks. And the ultimate cause turned out to be that there was a bug in the lease recovery. So if a file was abandoned, that is, a file was open for writing, and the client abandoned that file, there was a certain probability, and I estimated it to be about 1 in 10,000, that a mistake would be made recovering the lease, and that last block that was open for writing would be lost. And the reason why it's so high for mithril gold during that period is because mithril gold, yes, gets new software, but it also got a new version of Pig, which had a problem under certain circumstances causing lots of open files to be abandoned. And so the resolution here, at least in the short term, was that a new version of Pig did not abandon so many files, and made HDFS look good, or look better. We'll return at the very end to the question of what it takes to make HDFS look good. Down at the bottom, M45, the academic research cluster, somebody wanted to do research on what happens if you set replication 1 for the HDFS file system. You go for about a day, a node crashes, and you lose about 91 blocks that you were playing with. There are a few extras, okay, and they are pretty much attributable either to the least recovery problem or a bug associated with recovery of the pipeline. Folks who know a lot about the internals of HDFS know that as you write a file, it's a daisy chain of replicas being written. If one node in that daisy chain breaks, it's dismissed from the pipeline is put back together, and life continues with a shorter daisy chain. Unless you make a mistake and diagnose and think the wrong node is the bad one. If you make that same wrong mistake 3 times in a row, you lose the block that's being written. Okay. There's some consolation that, at least in this case, the client application sees a fault and could do client recovery or just the failure of a task that gets restarted. But still, it's a disappointment for HDFS. In today's code base, that is trunk of Apache, all of these problems are resolved. Okay, so at this point, there is no known bug within HDFS that causes blocks to be lost due to the misbehavior of HDFS. Okay. That's pretty good. So you say, well, 2009, we learned a lot, we fixed some bugs. Since then, we have sort of stepped away from the question of doing fault-by-fault analysis of lost blocks or reported lost blocks because we knew the problems, didn't see any evidence that there were new kinds of problems. But now, in 2010, people are looking about this replication 3 thing. Maybe this isn't such a good idea. I mean, it's 3 times the capital expense at the very least. And replication 2 might be pretty okay, depending on your perspective. If you use the same kind of statistical model I alluded to earlier, replication 2, maybe 2 or 3 times a year, a large cluster will just stumble on the coincident failure of nodes. But if you had some place where you could recover the data from, replication 2 looks pretty cool. And so what are the consequences? Does that have any consequences other than just being 2 replicas of stuff? Well, now we get to the question of correlated failures. When a cluster restarts, and I'm talking about everybody, all the processes started and restarted, a handful of nodes will not immediately join the cluster. And if only 2 nodes fail, and you're doing a lot of blocks with replication 2, the probability becomes real close to 1 that blocks will go missing. Okay. If you do a full power-on restart of the cluster, a bunch more nodes will fail, or fail to join the cluster. And thousands of the replication 2 blocks may go missing. The big problem here is that it can take the operations team a day or 2 to recover those. Most of those blocks are recoverable by just going to the nodes that didn't restart, giving them a little tender loving care, back massage, whatever it takes to get them back in service, and the replicas come back. Or fetching a replica from an alternate source. So still, it could be a good idea. The other kind of question is that the classic policy for HDFS had been that if a storage volume, a disk, whatever, a storage directory in HDFS speak, fails, becomes unserviceable, The policy was that that node resigns immediately from the cluster, and HDFS immediately begins replicating the blocks that had replicas on the node that resigned. Surely it seems that this is overly aggressive, that if you lose a storage volume, maybe you should just continue, especially if you contemplated having 12 disks or even more on a system. Isn't a pretty good idea. But suppose a node could continue service as part of the cluster, but could not restart. Okay. This is a new kind of correlated failure at cluster restart time. We tried this policy, discovered that when we restarted clusters, there was now a big handful, maybe an armful of nodes that were in the state that they did continue service when a volume failed, but cannot restart. And so that left us in the problem of correlated failures at cluster start time and the problem of trying to recover these missing blocks. So we retreated from that policy, began an initiative which we call disk fail in place. Barath from the HDFS team has a poster at the poster session describing his work in this regard. The sort of one-sentence answer is that if the system disk fails, that's the principal reason why you can't restart. If the system disk becomes a RAID volume, you'll almost certainly be able to restart the system. And so now we're again looking at the question of being able to continue with lost volumes. The other question is, are the bytes there when you need them? So during the last 500 days, I did a survey of all of the down incidents reported by the operations team that may be attributed to HDFS. That is, the principal complaint was, I tried to use the file system and it wasn't available. This table is about the same number of rows, but you need to understand these days there's lots more clusters. There's like twice as many clusters. So half of all clusters had no down incidents reported attributable to HDFS. From this list, mithril gold and nitro blue in the middle look a little anomalous, and those are our problem children. Because those are the clusters which get the new software first, and not only just new HDFS, but new everything else. They have the most diverse user community. Eric Sammer, immediately before this presentation, talked a little about that. And so they have a modest increase of incidents. But still, there's like 36 incidents over 25 clusters over 500 days. And so let's try to categorize those a little. So the first group is not HDFS software. This means loss of power, hardware failures, configuration errors, operation mistakes, and the like. And these were generally resolved by restarting HDFS. Two faults were bugs in HDFS. The cluster could be restarted, and the bug got fixed in the next release. 9 of the faults are attributable to exhausting space or objects, just using up either all of the available space, using up all of the available objects, that is the HDFS name node heap. And the system generally could continue after the resources were freed. 5 were attributed to user applications, basically users just demanding too much of the system. And maybe the system could continue when jobs were killed, maybe HDFS needed to be restarted. 4 cases were just not understood in complete detail. So looking at this list, that's an average of 1 event per cluster year. And so the question is what you might be able to do within HDFS to ameliorate some of these problems. Classic high availability, that is host failover, might have helped in like 8 of the 36 instances. So those are the cases mostly in the first category where it was a kind of fault that might reoccur, that it was not systematic to the load on the system, and it was isolated to the particular host. So if a host power failed, your HA might have helped. If it was a PDU, a power distribution unit that melted down, HA wasn't going to help in that case. And so that was 16 of the first category and 1 of the last category. And that's supposing that HA itself doesn't introduce any new failure modes. If the system was designed for continuous service, that might help more than classic HA. That means that you would be able to do release upgrades, change the operating parameters of the system, and do it in ways that did not interrupt service. What's interesting about classic HA may be that one component of that, the transfer to another host, helps a lot in the second problem. Careful management of the resources can help, taking the big stick after users who are using up too much of the resources. We've improved starting faster, so if the system is down, it gets back. Selecting tenants for a shared cluster, again, Eric Sammer's presentation helps. The rest of the story. So I talked about some engineering, doing a couple of surveys. I didn't talk about garbage collection, okay? Garbage collection is interesting in HDFS because if there's a promotion failure, the need to actually stop the world and compact the heap, that'll take about 5 minutes of life. Most of these are unobserved. 5 minutes, most things just continue. This is typically observed when there's some user, after 2 minutes of pushing the return key, gets depressed, starts and uses 2 more minutes to file a bug report. But garbage collection, we figured out how to get much better. For the largest clusters, it once was every 2 days. Now it's maybe not as often as every 2 months. The other thing to remember about availability of the system is HDFS is only part of the picture. For this survey period, for Mithril Gold, there are 6 incidents reported here. There were 7 reports of garbage collection, but there are also 12 deployments of Hadoop, which interrupted service for typically 2 to 4 hours. And there were 61 other interruptions of the cluster. So in our practice, if your job isn't running, HDFS is not the most likely cause of the service interruption. The final thing I want to do is remark that success at this scale is not just a development problem. The HDFS team did a great job. The HDFS is great software, but the team didn't do it alone. The reason people went to bed last night not worried about HDFS is at least partially to the fact that Richard's team was up all last night taking care of the operations issues with our installations. In addition to that, the solutions team not only was educating users, but carrying around the big stick and enforcing a little discipline on the user community. The quality engineering team did their work. As I mentioned, part of making HDFS look good is that MapReduce has to do right. The Pig Query Planner folks have to do right. The Uzi team needs to be right. And several hundred users have to themselves do the right thing and cooperate to take good care of the commons. So I thank you, everyone. Quick questions, or are we?
2 questions. Have you found any use from the tools that proactively warn you about disks getting bad? And the other question is, have you thought about proactively replicating, that is, using unused space to hold replicas even before you need them?
not so much, and not really. So the first question about using disk and sort of fault analysis tools, people are sort of aware of them. That never, bubbled up to the top thing. Proactively replicating stuff has mostly been looked at as a performance issue. There were some studies that say, if I've made a copy of a replica of something locally, should I just keep a local copy and maybe delete the other one? That's been studied academically, but not in a serious way.
So with the failure case, so I understand what happens when the drive actually fails. But what happens when it soft fails? If it starts having really crappy performance?
That's on the frontiers of research of HDFS performance. Okay. The question of looking at nodes that are only a little sucky is interesting. Dead is easier than almost dead or kind of sucky.
I know, I'm not sure if that's related to all of this that was discussed, but the HDFS append capability, I know that it was in development for some time and one was in and out. Do you know?
I'm sorry, I don't.
The HDFS, oh, here, should be closer. The HDFS appending capability, is that?
Append capability.
Append, right. I know it was kind of in the works, in and out, and then.
Append in HDFS is a long story. Version 18 did append almost. This was pretty problematic. We retreated from that. I'm teased about year 2009 doing that survey because it excludes winter of 2008, which is when we did some experiments with append. We retreated from that. 21 and later versions have a whole new implementation of the right pipeline that we believe is good.
Okay, so that you think it's sort of production quality?
And the next release of HDFS, yes.
And that's 21?
That's what we would call 23. Yahoo is... So the complexity of where Yahoo is another long story.
Got it, thank you.
But yeah, we're looking forward for append to be just right.
Yeah. So how did you improve garbage collection? You said it was running once every 2 days on the cluster, and you made it once every 2 months.
It's tuning the garbage collection parameters. You've got to adjust the new heap, the old heap. There's about the startup string that we use is like this long. And it was done,